Hey everyone, this is part 2 of how to use the Keyence LJS. First step was we got the part in the field of view. Now we're going to start playing with some tools. So the first tool that I always like to start with is a position adjustment. There are a couple different options here. Shape tracks is usually the most robust, but all of these can be used in their different areas. Center of a circle or gravity center of a cluster could also work for this because we're trying to find this dime as it moves around in the field of view. But for right now, I'm going to show you how to set up a shape tracks or a pattern match position. So once we get here, the first thing it's going to prompt us to do is register an image. By registering an image, you're giving it something to base off of. So once we have this part in the registered image, now when this part moves, the tools are going to track with it because it always kind of references back to this first one. And this is just for a position adjustment. So right off the bat, you get two boxes. The blue box is the area that we're going to search in. What this error code right here is, it's saying, you know what, we need more processing power because we're using a larger search field of view. This will happen a lot. Always click yes. Secondly, this green box is the object that we're searching for. So it always starts with a rectangle, but for this example, a circle would be best. So if you read this drawing right here, it says put them in kind of 3 different points across the circle. So I'm going to follow exactly what that says and draw 3 points around this dime. It doesn't have to be exact, just has to be kind of rough. We can click OK because our field of views are done. So it's automatically going to apply a height binarization. And what does that mean? If we go into 3D, which 3D is extremely useful for this, you can see that it applies that gray plane on my 3D image. And a really good field of view is to click this button and it's going to auto go to flat. And then you can see that gray plane right here versus your dime versus your blue surface right here, which is pretty small. So let's go back to 2D and we can learn a little bit more about height binarization. So there's 2 different forms of height extraction. There's a binarization or there's a grayscale. Typically grayscale will work really well because it'll convert it to an image that looks like this. And then for this part, inside this blue box, there's different ways that you can create a plane. The first type is a plane that just is best fit. So it's going to take all of the millions of different height points inside this entire box. It's going to average them and then make a best fit plane. And that can tilt. So if my part were to come in at an angle or the entire field of view were to come in at an angle, that part would tilt, or that plane would tilt with it. The other type is average height. So this is a static plane that will move up or down, but it's always going to be parallel to the sensor head. So if your part comes in angled or your sensor head moves, that plane is still going to be static, completely perpendicular to the sensor head. So I usually like to use a real-time plane. It's going to average it out a little bit better. And honestly, this looks pretty good to me. I'd click OK. And what happens next? So it's going to try to find a contrast between black, gray, and white. And once it does that, it creates all these little green dots across this whole area. And that is what the shape part of shape tracks / position adjustment is, or pattern search. But you see down here, we're starting to get a little bit of gunk, and we're trying to figure out, well, I need that, but do I really need that? Because it could throw up position adjustment in the future. So what you can do is if you click pattern region, and you click this eraser tool, we go in, I usually like to make it as large as I can, and it gives you this box. And what's really cool about this is any of this quote-unquote shape, so all the green dots and the blue dots, you can just erase them. So I can say, you know, this part of my image might cause some problem with shapes in the future because it's not super consistent like that top edge is. So I'm going to go in and I'm going to erase portions of it that I think would just cause issues. So I can keep going up here and erasing that edge. Again, doesn't have to be perfect, but works kind of like an eraser you would use in class. I can go up the same edge and do a similar thing. So it really helps getting rid of those kind of like issue areas of a part. I can click OK now, and that should be good. I'm going to move this part, and I'm going to run again. And as you can see, my shape is tracking with it. I'm going to move it again, run again, and my part moves with it. So that's a pretty good position adjustment. I always like to test, okay, let's put something angled in there. So I'm going to tilt add a part under this dime and see how it tracks. Because it is changing the shape quite a bit, but you can see even at an angle, this holds strong. So let's go and look at that height extraction when we're at an angle. So you can see it's still finding it because there was some of that dark area right there, but the vast majority of it stayed similar. And so what does that look like in 3D? So if we go to 3D and then we click this button right here, you can see the multiple planes that it creates. So this white plane right here is the best fit plane for the entire area, and this blue plane here is considered white pixels. So anything above that plane turns white, anything below this blue plane on the bottom turns black. So let me run this again, and I can show you how that middle plane stays pretty consistent, but that blue plane right there, that's pretty rock solid. So it's a position adjustment. Yeah, we can go into some more stuff. Another way you can position adjust it is if we use this pattern match tool again. And this is usually the easiest way to position adjust. At my factory, this is how I usually do it. Set up your circle the same way that you would before. Perfect. And then inside the height binarization, instead of using regular planes, we can use something called a freeform plane. And what this is it's a plane that blankets your part. So it actually will kind of wave in a 2D sense, or in a 3D sense. So you can see how the plane stays flat along this area, and then as we have a sharp spike up where that dime is, the plane actually moves with it. If I tilt it down in 2D, you can see it a little bit better. But that plane goes up. That plane, the bottom plane, goes up too. What this allows you to do is just search for just rough shapes. Because when you have a fast change in height, which is essentially a shape, you're going to get these green dots, and that plane is not going to be able to contour perfectly. So now we can look at that position adjustment just the same, and it's matching. And that's probably one of the fastest way to set up a position adjustment. From there, if we click position adjustment, and we go into assignment settings, you can have different position adjustment tools for different parts, or not parts, but different tools. So you can do one position adjustment that works for one, and then a different position adjustment that works for another. These are the tools that you're the target of the position adjustment. So I can say, you know what, I want this one to reference 0. And then here's your default for any time you add a new tool. You can also go directly into these specific settings, and you can say, you know what, I don't want that a shape to position adjust my theta. So what that means is if I had a part that was turning, it would move in X and Y, but it would not move in theta. So again, it all has its different use cases, but that's kind of position adjustment. Next up, we're going to learn about a profile tool.